Now we're going to move on to finding the nth term of an arithmetic sequence. Okay, you have used this word all of your lives and you call it arithmetic. Arithmetic. Now we're going to pronounce it a different, more fancy way to talk about an arithmetic sequence or an arithmetic series. An arithmetic sequence is the difference in an arithmetic sequence. The difference between any two successive terms is constant. So if you do 1, 2, 3, 4, 5, the difference between those terms is 1 because you add 1 each time as you go along. Okay, so if we have the sequence 2, 7, 12, 17, 22, you notice that the difference between 7 and 2 is 5, 12 and 7 is 5, 17 and 12 is 5, and 22 and 17 is 5. In other words, you take the number, any two consecutive numbers, take the number that's to the right and subtract from it the number that's to the left. That's what we call the difference in terms. So for this one, it would be 1 minus 3 is minus 2, minus 1 is minus 2, minus 3 plus 1 is minus 2, minus 5 plus 3 is minus 2. Remember, you're going to take the term on the right and subtract from it the term immediately to its left, and that's what your difference will be. So it would be a sub 4 minus a sub 3. Okay, we use the letter D to show what the common difference is. And the formula for the nth term of a sequence with the common difference D is a sub n equals a sub 1 plus quantity n minus 1 times D. You need to write that down and remember it. Keep it handy because that's what we're going to use to solve these problems. Now let's see, how do we get that equation? Well, if I have a sequence of a sub 1, a sub 2, a sub 3, and so on and so forth, the first term is just a sub 1. The second term is going to be a sub 1 plus whatever the difference, whatever the common difference is. So if it's 1, 2, 3, 4, 5, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So that's how you're getting your consecutive terms. The third term would be whatever the second term is, and we already said that the second term was a sub 1 plus d, so I'm going to take my a sub 1 plus d and add d to it to get the next one. So that would be a sub 1 plus 2d. For the fourth term, it would be a sub 1 plus 2d, which is what we got for our answer here, and we're going to add 1 to it, or add d to it, so we'll have a sub 1 plus 3d. See a pattern forming here? So the fifth term would be a sub 1 plus 3d plus d again, which is a sub 1 plus 4d. So the pattern here is, if you take a look at what the subscript number is, that's going to be one more than the n that we're looking for. So in other words, we have, for the fifth term, we have 4d. So a sub n is going to be the first term plus 1 less than the number of terms we're looking for times d. All right, let's get an example here. Find the 27th term of negative 4, negative 1, 2, 5, 8. Now you can go ahead and figure out what by continuing your sequence out until you get the 27th term and take a lot of time and probably make a mistake in adding somewhere along the line, or you could use your formula. You know that D is going to be 8 minus 5, or 5 minus 3, or 2 minus a minus 1. It doesn't matter. Take a term, subtract the term directly to the, or immediately to the left of it. So we have our D equals 3. We know that our first term is negative 4, so there's our a sub 1 component. And we know that the number of terms, that n is the 27th term, and we want to find the 27th term, so n equals 27. So now we just plug in. A sub 27 is going to be negative 4 plus 27 minus 1 times 3, which is 74 when you work it out. So the 27th term is 74. Okay, go ahead and do your checkpoint number 1 and come back and we'll move on. Next example, find the formula for the nth term of the arithmetic sequence -5, -1, 3, 7. So now we're not going to find a number answer, we're going to find the formula to find the answer. So once again, a sub 1 is -5, d is 7 minus 3, which is 4. So a sub n is going to be -5 plus n minus 1 times 4, and it's the n that we're looking for. So let's go ahead and expand this, distribute the 4, so you have -5 equals 4n minus 4. So a sub n equals 4n minus 9. So go ahead and do your checkpoint number 6. Another example. Find the number of terms in the arithmetic sequence 7, 10, 13, and so on to 55. Okay, what is it that we know? We know that this is the formula we're going to use. We also know that we're looking for the number of terms. So we're looking for n. And we know that our final term, our a sub n, is actually 55. So I would say 55 equals the first term, which is 7, plus n minus 1, because we're looking for n, and our common difference is 13 minus 10, which is 3. So now if you distribute your 3, 55 equals 7 plus 3n minus 3. 55 minus 3, I'm sorry, 7 minus 3 is 4, and 55 minus 4 is 51, equals 3n, so n equals 17. So the number of terms that we're looking for is 17. So go ahead and do your checkpoint number 7, and I'll see you in class.